Hi, I'm Jerry Rodriguez, and I'd like to tell you a little bit about my new book. I put together the Astrophotographer's Guide to the Deep Sky to help answer the question that we all face. What should I shoot tonight? Like most of my books, this one started as a series of notes for myself. I've been collecting a master list of interesting photographic targets for many years, and this book is a result of that effort. It'll provide a reference to the best and most beautiful objects in the deep sky that you can shoot with your own equipment. It's got the biggest and brightest objects, as well as some really faint and challenging ones. The book is organized in several different ways to help you get around and find objects to shoot. Let's go back to the table of contents and see what we've got. Let's go to the Master Objects list. It contains more than 400 objects. It's got the best galaxies, nebula, star clusters, double stars, constellations, and supernova remnants in the sky. The Master Objects list is sorted by right ascension by default, but if we click on a column heading, we can sort that column alphabetically or numerically. We can sort by name, object type, catalog number. Constellations don't have a catalog number, but we can see if we scroll down, we'll have all of the Messier objects here listed as M objects. And we've got a bunch of NGC objects also. We can sort by constellation or right ascension, size, separation, magnitude, notes, or framing is a good way to sort too if you want to shoot for a particular focal length for a telescope or lens that you happen to have. If you sort by that focal length, you'll see what you can shoot. The Master Object list also contains links to more than 250 individual object image pages, such as this one of the double cluster. Objects are also listed by season, with individual thumbnails for the objects. If we click on a thumbnail, we'll go to the image page for that object. Individual image pages also contain some basic information about the object and exposure data about the image, such as the camera field of view, the scope, focal length, focal ratio, and camera that the image was taken with, as well as the ISO and total exposure time and any filters that were used. This data box also gives an SQM meter reading. That's the sky quality meter, which reads the brightness of the sky in magnitudes per arc second. And you'll be able to use this to compare to your own observing site, so that if your observing site has a brighter sky, you'll probably want to give the images more exposure time to achieve the same kind of quality that you see here. Down at the bottom of the page is a finder chart that shows the location of the object in the sky in a wider field, just to give you a general idea of where it is. And also some basic data about the object itself, such as the catalog name, common name, object type, magnitude, size, constellation, and the right ascension and declination for where the object is located. Individual image pages will show you the kind of quality that can be captured with a DSLR for these types of deep sky objects. Most of the images are also fairly deep, and they'll give you an idea of the extent of the faint nebulosity in the field for a particular object. Some of the wider fields that go deep, such as this one of the Taurus molecular cloud, have a lot of objects in them. And in those images, we have a mouse over that will identify the individual objects in the image. So by looking at the exposure information that's included with each image, you'll know what focal length it was shot at, and the exposure and sky brightness information will give you an idea of where you can start based on your own equipment and sky conditions. Let's go back to the table of contents now. Objects are also listed by the All Sky chart. Here we've got the equatorial region, we've got the North Polar region, and the South Polar region. Now each one of these charts is an image map, which means that if you hold your mouse cursor over a constellation and it turns into a hand, that we can go to an image of that constellation. Let's try Auriga. So here's the constellation of Auriga. We can see that this is also a mouse over where you can see the constellation boundaries and the constellation figures, the Bayer designations for the bright stars in the constellation, along with the popular names for the brightest stars. You can also see that the deep sky objects are present in some of these constellation images. And if we go to the constellation image map, this shows the deep sky objects and their designations. And again, if you hold your mouse cursor over one of these objects and it turns into a hand, that means we can click on that individual object and go to it. I'll go back to the table of contents again. And constellations are also sorted by name alphabetically. And if I've got an image map of that constellation in the book, it's a link, and you can click on it and go to it. Constellations are also sorted by season for the image maps. The book also has a very powerful search engine. You can find an object simply by typing in the object designation or its name. For example, let's type in M35, and we'll get results with every page in the book that mentions M35. Usually the first listing is the image page for that particular object. Now we can also go through the book linearly, like you would go through a traditional paper printed book. Just by clicking on the next button, you'll go through every single page in the book. You can go forward, or you can go backward, or you can go up one level to the thumbnail seasonal images. Let's go back to the table of contents and take a look at the local sidereal time calculator. Sidereal time is basically the equivalent of the right ascension that's transiting the meridian at that time. This is when an object will be highest in the sky and best placed for photography. We use computer system time. We'll see we're at about 21 hours. This is in 24-hour time, which is the equivalent of about 9 p.m. local time. And we can see down here that 2.5 hours sidereal time is equivalent to 2.5 hours of right ascension. So if we want to see what's transiting the meridian at 9 o'clock local time, we'll just go back to the master objects list and scroll down the right ascension column till we get to about 2.5 hours. And 2.5 hours is about 2 hours and 30 minutes. So we can see here that Cassiopeia and Ursa Minor are transiting the meridian, and we can see what objects are best placed for shooting at 9 o'clock that time. I hope this book will help you to figure out what to shoot and show you some of the really beautiful objects that are up there in the deep sky, and tell you where they are and when best to shoot them. Thank you very much, and clear skies. You can order the book at astropix.com. ASTROPIX.